hashtag nerds together strong. I always put a new hashtag. I think that's a good one for you guys. All right. So let's start a little bit with conics, a little bit of what we should know, and if we don't know, it's okay. Unit circle is a circle centered at the origin with a radius of 1. So let me put that down. A unit circle is a circle centered at the origin with r equals 1. Remembering the section of circles from geometry algebra 2, we have an equation. So the unit circle, here's my unit circle centered at the origin. And remember, we said that radius was 1. And so hopefully you remember from your algebra 2 days that the equation of a circle is x squared plus y squared equals 1. That's from your, x squared plus y squared equals r squared. So there it is. And you probably saw it one of two ways, the equation of a circle. You probably saw it like, what do they use for center? HK. So you probably saw it like x minus h close it squared plus y minus k close it squared equals r squared. That's the equation of a circle centered at the origin. Maybe you saw it in this type of notation, x minus h over r close it squared plus y minus k over r close it squared equals 1. Sometimes they call that the standard form. There's one more. Well, it's the same one, but sometimes they put a subscript down there, r of x and r of y. They call those radii. It's just plural for more than one radius. What happened, miss?
Sorry, Travis, I didn't get...
Oh, sorry, miss. There you go.
Thank you.
And as long as Rx equals Ry, you have a circle. If Rx does not equal Ry, then you have a ellipse. Does that sound familiar to you guys? Does that look familiar or no? No? Not even a little bit? Oh, man. Okay. When we start getting to graphing these things, we'll talk more about them. Actually, we should probably talk about them before you guys take the SAT. When do you guys take the SAT?
In March.
In March? Oh, okay.
January and March.
I thought there was one in the fall semester.
Yeah, I think
October?
I thought that was our PSAT.
Yeah, before we take the SAT, we should go over circles again. So remind me 2 to 3 weeks before. That way we can have them. Okay. All right. So I think that's all you got to know about that. Let's see. Remember, the radius is 1. So we have some special angles on this unit circle. Yeah, we do. All right. So here we go. I guess let's talk about those special angles, right? So draw a generic unit circle. Takes up most of that space. Between the axis, you should have gaps of 30 degrees. Chav, what does that mean? So I'm going to emphasize quadrant 1. So this right here, that's going to be 30 degrees right there like so. And then this gap right here, that's going to be a 45-degree angle. And then this one here in black, from the x-axis to that line in black, that's going to be a 60-degree angle. So I want you guys to observe that between the axis, so here it is, that gap in orange and that gap in burnt orange, those gaps are both 30 degrees because this guy is 90. And then between these other gaps, so these gaps in purple, and I know there is not down to scale, those gaps are 15 degrees. See, 30 plus 15 gives you 60, and 45 plus 15, 30 plus 15 gives you 45, sorry. And then 45 plus 15 gives you 60. Does that make sense, guys? Yeah, I hope I corrected myself. You okay, Melonis? Hit me.
No, I'm just like, I can't see.
Yeah, I'm sorry. I definitely said, I did say something wrong in the beginning. I said 30 plus 15 was 60. It's not. 30 plus 15 is 45, and then 45 plus 15 is 60. So the inner gaps are 15 degrees, and the outer gaps, the gaps between the axis and that ray or that segment, is 30 degrees. Cool or not cool? Cool. And then you continue with that pattern. So we're going to go 30 degrees away from the 90. And it's not down to scale. I'm just going to put everything in red here. So what's 90 plus 30? 120. And then I'm going to go another 15 degrees from that. 135. And then I'll go another 15 degrees from that. And that's 150. Of course, that 150 degree, guys, I know that I'm not putting it in there, but that 150 degrees is the measurement of rotation from here to here. So we're aware of that, right? Okay, and then this dude right here is 180 degrees. Make sure to put the degree symbol. Some of you didn't put the degree symbol, and I had to take out, don't worry, I just took out like a point. So if you notice your grade book on If you notice your grade on Gradebook, it said like 99, 98, 97, something like that. I'm very generous when it comes to the homework. We don't expect perfection. What's 180 plus 30? 210. You're good. Or 210, that's fine. 210 plus 15? 225. 225 plus another 15? 240. 240 plus 30? Okay, that one we should know already, right? The 270 no matter what. 270 plus 30? 300. 300 plus 15? 315. 315 plus 15? And then finally, when you do a full revolution, and that's how you can verify that you did everything correct. So the gaps between the axes are 30-degree gaps, and the gaps in between those are 15-degree gaps. Cool or not cool? Okay. What's up? Hit me.
Wait, can you just say that again?
Yeah, maybe I'm not using proper English. It could be English, but I can't speak English or Spanish. The gaps between the axes, see that gap there? That's a 30-degree gap. And I know it's not drawn to scale, but this gap right there should also be a 30-degree gap. Because that black line there, that's 60 degrees from there to there. So then this gap here is 30 degrees. This gap here is 30 degrees.
But, okay.
180, 150. And then the inner gaps, the gap in between these angles, the gap between 120 and 135, that's 15. This gap is also 15.
Okay.
You see that?
Yes.
Or are you just telling me that?
No, I did.
Okay, faux show? Okay. Hit me, miss, hit me. What's up?
Before we move on, could you go back to just up a little bit?
Yeah.
I didn't get to see it.
You're good. I do record all this, guys. That's all of it is being recorded. I usually don't edit anything out because it takes time to edit videos, and I usually don't have that much time. So I just so usually it's just raw, whatever. If we talk smack about someone, it's recorded. Okay, are we okay so far, guys?
Yes.
All right, go to the next page. And it says, because of these special angles, we can derive the coordinates by looking at two special right triangles, 30, 60, 90 and 45, 45, 90. I don't know if you remember, but if you remember from the past, there's a property for 30, 60, 90. It's n square root of 3, and 2n. And for the 45, 45, 90, it's n, and then n square root of 2. Do you remember a formula like that? Something similar or no? Don't worry, we're going to talk about it. So, and yeah, it's right there, guys. Don't worry, this is all being recorded, like I said. So if you miss something or if you don't want to write anything, just listen and I'll upload it. If you guys want me to upload it super fast, I can upload it tonight, so you can reference it immediately. All right, cool. All right, so I want you guys to observe this. So wherever you see that little degree symbol, you're gonna put the degree. So that's a 0, and then you're gonna put, what's the first one? No, the first one is 30, and then the next one is gonna be, and then the next one after that, and then this guy right here. There it is. So put those in. And then we already know this is a unit circle. So that means this radius, the distance from here all the way to here, that distance is 1. So then that means this coordinate has to be 1, 0. And then at 90 degrees, you're going to call that 0, 1. The x coordinate is a 0. The y coordinate is a 1. Is everyone okay with how we got those values? Okay. The radius is 1. So that means the distance from the center to the edge of this. So you see this part that I'm highlighting? That right there has a distance of 1 because that's the radius. So that means this distance here is also a distance of 1 because that's the radius. Does that make sense?
And that's always?
For a unit circle, because that's what it's called. It's called a unit circle, so it's 1 unit away from the center. I thought I saw some. Okay, yeah. For a unit circle. If they told you that you have a centered at the origin with a radius of 5, then we would make the radius of 5, so that would be 5, 0 instead of 1, 0. You know what I mean? Okay. Is everyone okay? Okay, I'll try to pay attention to what I'm saying because sometimes I'll say something that's not. Okay, I think we're correct so far. I know after lunch I always get sleepy, guys. So this time I got my little energy drink. So make sure that. Yeah, and it's a little guy, see? So I don't want to take in too much caffeine because in the past I was really bad with caffeine, like really bad. So I'm trying to be good. I'm trying to be better. Okay, are we still okay so far, guys?
Yes.
Okay, now Now that we know that, so let me see if I can use the copy paste feature there. So I'm gonna look. You see this 45, and I'm gonna draw this like so. And here's my right angle, and maybe I just gotta look at because I did a software update with this app, but I see that I'm not liking what it's doing to these lines. They're too thin. But the one is what it used to be, and now I guess I have to make it thicker to 2, I guess. But anyways, that's besides the point. I'll whatever. You see that red triangle right there, guys? So I'm gonna go to this page where it says intentionally left blank, and this is supposed to be the same triangle. This is a 45, 45, 90-degree triangle. 45 there, 45 there. There's my right angle. This hypotenuse has a radius of 1. So put a 1 right there. And I'm going to use, let's see, do you want to do Pythagorean theorem first and then do the property, or do the property? What do you guys want? Pythagorean theorem. Okay. So Pythagorean theorem, if that's 1, I'm going to say this is n, and I'm going to say this is n. I'm trying to figure out what n is. So if I want to figure out that segment, here's what I'm going to do. Pythagorean theorem. I'm just going to go n squared plus n squared equals 1 squared. Are we still okay? Okay. So I see that I have 2 of them right here. So I'm going to add them up. So that's 2n squared equals 1, because 1 squared is 1. And I'm trying to figure out what n is. So I'm going to divide by 2 to get rid of that 2 in front of the n squared. So I have n squared equals a half. What do I got to do to get rid of that square? Square root it. So I'm going to square root. So n equals the square root of 1 over the square root of 2. That's law of exponents. The square root of 1 is 1. So I have 1 over square root of 2. And I'm okay with that answer. But if we want the square root in the numerator, that's called, what is that called, by the way? You guys remember? Did I tell you guys yesterday? Or it was the other group, right? The AP, the honors group. Rationalizing the denominator, or rationalizing your fraction. That just means that you don't want a square root in the denominator. So here it is. How do I cancel it out? By multiplying it by square root of 2 over square root of 2. Square root of 2 over square root of 2 is just 1. So it's going to keep the same value. When you do that, you're going to have square root of 2 over 2. So that's what this is, square root of 2 over 2, and that's what that is, square root of 2 over 2. Are we okay? You would have gotten the same answer if you would have gone over here to use this property, and you would have written, I like to write what this equals down here. So it says that 1 is that n square root of 2, whatever you have under the 90 degree. So I will put a 1 there. And then you could have just gone right to this, n square root of 2 equals 1. Child, that's not the same thing. Yeah, it is. Look, divide by square root of 2, divide by square root of 2. And you get n equals 1 over square root of 2. Well, that's what we got. That's what we got right here. That's what we got right there. See? And then if you rationalize this, multiply this by square root of 2 over square root of 2, you get the same answer, square root of 2 over 2. Cool or not cool? Okay. Is anyone freaking out? Okay, so that means, what does that mean? On the 45, 45, 90 triangle, this horizontal displacement is square root of 2 over 2. This vertical displacement is square root of 2 over 2. So I come back here. And what am I going to put right here for the x-coordinate? Well, that x-coordinate is this distance right here, which we just got what? Square root of 2 over 2. And what am I going to put for the y value? There you go. Do you see how we're doing it, guys? Okay. So now that you guys are satisfied that it works, that our properties work, I'm just going to use the property for the 30, 60, 90 triangle. Is that okay with you guys? Okay, so now focus on this blue one here. Remember, here's my 30 degrees. Here's my 60 degrees. So the horizontal axis is my long leg, or the horizontal displacement is my long leg. My vertical displacement is my short leg. So I'm going to come over here. So here it is. Here's my triangle. Let's see if I can draw it. So here's the 30, here's the 60. And I'm going to put the properties right here. 30, 60, 90, n square root of 3, 2n. Are we still okay? Okay. So wherever the 30 degree aims, that's your short leg. So this is n. Wherever the 60 degree aims, that's your long leg. So this is n square root of 3. And wherever the hypotenuse is at, that's your 2n. 2n. So there it is. Those variables tell you the relationship between short leg, long leg, and hypotenuse. Are we still okay? Okay, now because it is a unit circle, my hypotenuse is 1. Is everyone okay with that? Because that's how we start. And Taylor, we okay? Those a property for 30, 60, 90 triangles. So that was given from geometry. It's okay if we don't remember, but from geometry, those are the properties of a 30, 60, 90 triangle. Okay. And we know they work because that's why we started with the 45, 45, 90 because it's an easier one to do. We could do Pythagorean theorem as well, but now the sides are not the same. That's why it was easy to do the 45, 45, 90. Not that it can't be done. It can. But I'm scared that I might lose someone. So, are we okay, Miss Taylor? Yeah. We're doing okay. Yeah. All right. So check. And is everyone okay with that 2n equals 1? All right. So here we go. I'm going to put a 1 right underneath that 2n. So I'm going to write 2n equals 1, and I'm going to figure out what my short leg is first. So how do I get n by itself? Divide by 2. So my short leg is a half. So here's my short leg. I'm going to write 1/2 right there. Oops, I should have read it in blue. That's fine. That's fine. Are we still cool? Okay, now this says that my long leg is 1/2 times square root of 3. So you can write it like this. UH actually writes it like that. Whenever you start doing UH quizzes, which this might be one of the first ones we do, you'll see it like that. I prefer that you write it with the square root of 3 in the numerator and the 2 in the denominator. Do you guys see how we're getting that? Okay, so now we got everything. This is a half. This is a square root of 3 over 2. There it is. All right, we're going to go back. The horizontal displacement is square root of 3 over 2. When I say horizontal, did you guys already talk about that in physics, displacement? No? Oh. I'm talking about the distance from the endpoint, from the center to this edge. That's called a horizontal displacement. So when I say vertical displacement, let me get my little laser. Here's my little laser. When I talk about vertical displacement, it's the distance from here, the x-axis, to the top of that line. That's vertical displacement. Cool or not cool? Okay, so here we go. I'm going to come back here. And on that blue triangle, what do I put for the x-coordinates? What was my horizontal displacement? Yeah, it is a safe space. You're good. And what is my vertical displacement? 1/2. So there it is. Does everyone see how we got those coordinates? Okay. All right. There is another 30, 60, 90 triangle in there. Let me highlight it for you so you can see it. Do you see this triangle right here? That's another 30, 60, 90 triangle. But this time the 60 degrees is right here, and the 30 degrees is right there. So what does that mean about my coordinates up there? I'm going to flip them. The x becomes my y becomes my x. So here we go. So what do I put for the x coordinate? 1/2. What do I put for the y coordinate? Perfect. Look at that. Is that cool or what? All right. I believe we can now do 2/3 of the unit circle. Let's go to the next page or to the last page here. And look, we got a nice brand new clean unit circle. We're going to go slow. Don't worry. Are we okay so far?
Yes.
Don't worry. Okay, so here we go. Let's fill in the degrees first. You guys are going to guide me. We're going to start at 0 degrees. So here I am. I start, put a 0 right there. And then what's this first one right here? 30. What's the next one? 45. What's the next one? Perfect. What's the next one? 90. What's the next one? Yep. What's the next one? What's the next one? At 15, 150, sorry. And then what's the next one after that? And that's how you can check. That definitely has to be 180. What's the next one after that? 210. What's the next one? 225. What's the next one? 240. What's the next one? And that's how you can check. That better be 270. That's okay. What's the next one after that? 300. What's the next one? What's the next one? And then the last one? And yep, you did it right. 1 revolution is 360. Why? Okay, real quick, kind of going off on a tangent, but not really because it's still related to this. It's just not necessarily the most important. Why the number 360? Like, who said that 1 revolution is 360? Now, I'm not a history buff. Maybe talk to Balderas. I'm not sure. Maybe Google it later on. I believe it was the Babylonians that said 360 is 1 revolution. You know how they got that number? That number came from about approximately, they did pretty good. That's approximately what the Babylonians said how long it takes for Earth to revolve around the sun. How many days in a year?
365.
Oh, they came pretty close. They put 360, and it just turned out that now it works perfect. 360 fits into everything, but that's how it came up. Now, I'm not a history buff. I hope someone on the internet doesn't come around my video and like, that's totally wrong, and then starts putting comments. You guys later on, if you have downtime, like Babylonians, 360 degrees, and see what it says. And if I'm wrong, let me know, guys. Fill me in, and then the next class. Yeah, and then the next class after that, I'll be like, the class of 2027 told me, I was telling them for the longest time is this, but no, they told me that it's this. I don't know. That's what someone told me, and I just assumed it was true. I still to this day haven't even Googled it. So maybe you guys can Google it and figure it out. All right, here we go. Let's fill in the coordinates, the ones that we know for a fact. What's the radius of this unit circle? So let's fill in those immediately. So this one's 1, 0, because that radius is just 1. The one at 90 degrees is 0, 1, that coordinate. The one at 180 degrees, -1, 0. The one at 270 degrees. Perfect. Yeah, perfect. There it is, guys. All right. What did we get at 30 degrees? Well, I don't know. Let's scroll up, see what we got. Square root of 3 over 2 for the x. So, right, square root of 3 over 2. And what did we get for the y? 1/2. Why did it turn to blue? 1/2. Or purple, sorry. All right. What did we get at 45 degrees? Square root of 2 over 2. Square root of 2 over 2. What do we get at 60 degrees? 1/2. Perfect. Chav, how do we do the rest? Okay, guys, it's the same magnitude. Notice at 120 degrees, that's going to be the same as at 60 degrees. If you were to fold the y-axis, this dot here would land on that dot. It's use symmetry. So the numbers, the magnitude stay the same. The only difference is that in quadrant 2, what's negative? The x. So make the x negative and keep the y positive. So at 120 degrees, what do I write for the x? And then what do I write for the y? Square root of 3 over 2. Perfect. At 135, what am I going to write? And for the y, just square root of 2 over 2. And I should have said 135 degrees. Sorry that I just said 135. At 150 degrees, what am I going to write? And there you go. In quadrant 3, the magnitudes stay the same. Just make sure you don't mix them up. In quadrant 3, the magnitudes stay the same, but both of them are going to be negative. So what do I write at 210 degrees? Now be careful. Yes. Negative square root of 3 over 2, comma, -1/2. Just be careful, guys. Just slow down, because sometimes I see it all the time, especially when you guys go fast, you switch it. Look at that one right there and be like, oh, okay, that's the same as that. So magnitude's the same, both negative. And then the next one, that's the easiest one because it's always going to be the same magnitude, just both negative. So at 225, what do I write? And the same thing. At 240, what do I write? Yep. All right. And the fourth quadrant, the x is now, and the y is. So what do I write for the x coordinate here? 1/2. And then for the y? Perfect. What about the x and y coordinate at 315 degrees? Perfect. What about at 330 degrees? There you go. See, that's not so bad. All right, here we go. We need the radians. Relax. Oh, I shouldn't have said that. Let's put the radians that we know. I should have said, like, what are we missing? And have you guys answer, we're missing radians, but instead I just gave you the answer. So, yeah. What are we missing?
Radians.
Yeah, we're missing the radians. LOL. All right, here we go. Let's put the basic ones that we know for a fact. We know that this one's 0 because we haven't moved yet. At 90 degrees, what do I call that one? Pi, half of pi or pi over 2. At 180 degrees, that's a whole pi. And then at 270 degrees, that's 3/2 of pi, or you can say 3 pi over 2. And then once I've done a full revolution, how many is that? 2 pi. Okay. At 30 degrees, so here we go. So I'm going to use my little blank space here. I'm going to come over to, or you can use the margins here. I guess that's fine. 30 degrees. And what do I do to get a degree to a radian? I multiply this by what? Not
By 180 over
is it 180 over pi or pi over 180? Pi over 180. So 30 degrees, there's my little dot, times pi over 180. And 3 goes into 18 how many times? So pi over 6. Yeah, you're right. So I'm going to write pi over 6 at the 30 degrees. Pi over 6. I'm using that dash to be my little divisor. All right, 45 degrees. So I'm going to come over here. I'm going to write 45 degrees times pi over 180. And here's how I do it, because just looking at it like that, trying to go fast, I don't know. But I know this. I go, in my head, I know what 45 plus 45 is. That's 90, and that's 2. And that's 180. So then that means 45 goes into 180 how many times? 4. So pi over 4. I always just do it like that. I think that's called grouping or symmetry by grouping, if you want to be technical. So that's a pi over 4. Yay or nay? Perfect. Now the last one at 60 degrees, I guess you could technically look at 30 degrees and be like, if 30 degrees pi over 6 plus pi over 6 is 2 pi over 6, which reduces to pi over 3. That's not the only way you could have done it. You could have done 60 degrees times pi over 180, and you could have said 6 goes into 18 3 times, so look, pi over 3. There's so many different ways. It all depends on your learning style and what you think is best. Are we okay? Okay, we can continue that pattern and fill in the entire circle. I think it's a little cumbersome to do that. Here's what I think. Put your pencils down. So let's see. Which one am I going to focus on? I'm going to focus on the 120. So you see this in burnt orange. Don't worry. I'm going to give you guys time to write. But you see that in burnt orange. I already know that that's the same distance as the distance from here to that one. We call this a reference angle, right? So we know that this reference angle, because it's quadrant 1, is pi over 3. So I am pi over 3 away from a whole pi, or 1/3 pi. So if I want to know this angle right here, plus 1/3 pi, gives me a whole pi. So what do you think this big angle is right here? Yeah, 2/3 pi. Do you guys see the logic of how we did it? So let me explain really fast, and then I'll let you guys write. So that means, so I said, what is this gap right here? That when I add that burnt orange line, I get a whole pi. Well, if that burnt orange is 1/3 of a pi, this highlighted region right here, that rotation has to be 2/3 pi, because together I have a whole pi. Does that make sense to you guys? All right, so there it is. So using that logic, now you can write. I'm going to write right here. What am I going to write? 2 pi over 3. Keep the denominator the same. 2 pi over 3. And then write what you got to write. Okay, using that same logic. I'll zoom in. Using that same logic. So I'm going to erase that burnt orange. This that I'm writing in burnt orange right here, that is pi over 4. So I'm pi over 4 away from a whole pi. What do you think this fraction is? 3/4 pi, or 3 pi over 4. Do you see what we're doing? Okay, using that same logic again, I'm going to erase that burnt orange. And I'm going to put that burnt orange right here. That burnt orange right there is pi over 6. What do you think that radian is from the positive x-axis to 150 degrees in radian? 5/6 pi, or 5 pi over 6. Do you see what we're doing, guys? Okay, same logic again. We're going to continue with that pattern because I think we're onto something. This gap right there, that is a pi over 6. So I went to whole pi plus 1/6 pi. What do you think that is?
7 pi over 6.
Perfect. 7 pi over 6. Look at you guys being nerds. Continue that pattern. Sorry, I hope I didn't offend anyone by saying that. Yeah, nerds together strong. What's this denominator? I guess let me show you first. I should guide you, right? Yeah, that denominator is 4 because this right there is pi over 4. So pi over 4 plus a whole pi. 5 pi over 4. Yeah, you can turn that pi into 4 pi over 4 plus 1/4 pi. That turns to 5 pi over 4. All right, what's the next one? 3 in the bottom. Yes. Pi, 4 pi over 3. Leave the safe space, guys. Yeah, it's 4 pi over 3. 4/3 of pi. All right, let's see. Let's continue. Let's continue this, that right here. So what do you think this one is here? You got to keep that same denominator. So the denominator is still a 3. I guess let me help you guys. This right here in burnt orange, This right here in burnt orange, that's pi over 3. I'm pi over 3 away from 2 pi. What is the numerator? I think I heard you say it. No, not 3. I think I heard someone say it. 5 pi. Yeah, 5 pi over 3 plus pi over 3 is 6 pi over 3. And 6 pi over 3 is 2 pi. Do you see what we're doing, guys? Look, we're going to do it again. Check it out. We're going to do it again. This distance right here, this reference angle, that's pi over 4. You're pi over 4 away from a whole revolution, from 2 pi. 7. 7 pi. Oh, let me use red. 7 pi over 4. Do you see how we're doing it? All right, let's do it again one more time. So look, you're pi over 6 away from a whole revolution. 11. Good job. Look at you, miss, being a beast at math. Are you guys seeing this? How do we feel? Okay, let's take a pause really quick. I want you guys to observe, notice the pattern. Don't be a robot. Can you be a robot? Yes, but try not to because your memory will fade. Does everyone know how we got all those radians? There's so many ways to do it. You could always take this number, the 150, and the 150 degrees, and you can multiply that by pi over 180, and you'll get this exact answer. This is the exact radian because it has a pi on it. If I were to put the decimal, like whatever comes out of your calculator, then that would be the approximate radian, not the exact. Are we okay?
Yeah.
All right, I want you to notice, observe, what did you observe? You got to know quadrant 1. So quadrant 1, you got to know. In quadrant 2, notice that the integer in the numerator is 1 less than the denominator. Don't be a robot, that's for a reason, that's because of that reference angle. So you got to keep the denominator. 6, 4, 3, keep the denominator, 3, 4, 6. Got to know the pi. In quadrant 3, the integer in the numerator is 1 more than the denominator because of the reference angle, because we're adding that. In quadrant 4, whatever the denominator is, double it and subtract 1. Double of 3 is 6, subtract 1, 5. Double of 4 is 8, subtract 1, 7. Double of 6 is 12, subtract 1, 11. Why? Because of that reference angle. If you add that reference angle, you'll be at that 2 pi. Is that making sense, guys?
Yes.
Are you starting to see, like, okay, I'll slow down. I know that in the past people just showed you and they didn't show you like the patterns, but I'm trying really hard to open your eyes so you can see like, oh, it's just a shift, a different way of thinking to make you more efficient. Cool or not cool? Okay. Now the last thing, which I thought when I do this at the end, I feel like we have a better retention of this. I used to do it in the very beginning, but now I do it at the end. All right. So here in the very bottom, there's plenty of space. I'm gonna ride SOHCAHTOA. Child, why are you writing SOHCAHTOA? I'm scared. Don't be scared. We're okay. I'm going to draw a general unit circle. It doesn't have to be perfect. And I'm going to draw a reference triangle. I'm going to say that's my angle theta. And I have some coordinate up here, and I'm going to call that x, comma, y. Are we still okay? Okay. This horizontal displacement is my x coordinate. Does everyone agree that that is your x coordinate? And this vertical displacement is my y coordinate. Are we on the same page right now? Like, is everyone like okay with everything? Okay. According to this SOHCAHTOA, according to that acronym, I can rewrite this and say sine of that angle is equal to y divided by 1, because it is a unit circle. Anything divided by 1 is itself, so I can just say that sine theta is just y. Do you see what we did there, guys? No? Okay. All I did was I said sine and something opposite of our hypotenuse. So I went sine of that angle is y divided by 1, opposite of our hypotenuse, right? Opposite of our hypotenuse. And then, well, y divided by 1 is just we're good? For sure. You're not just telling me that.
Yes.
Okay. All right. Using that same logic, I'm going to go to cosine. Cosine of that angle. So cosine of that angle is adjacent of our hypotenuse. So I'm going to write x over 1. And x divided by 1 is just x. So anytime I say cosine, I'm just talking about x now. Or cosine of that angle. Cool or not cool? Okay. Tan. Tan of that angle is what over what? y over x. Chop, so why are you showing this? Why are you showing me this? And how are we going to use it? Okay, I think we're ready. You guys ready? I'm going to write, what am I going to write? Let's start simple. Cosine 30 degrees, cosine pi over 6. All right, I'm going to go to 30 degrees. This says cosine of 30. So look what it says. It tells me that cosine is what? X. So I'm going to go to 30 degrees, and I'm going to look at my x. At 30 degrees, what is our x? So that's what I'm going to write. So I'm going to write cosine of 30 degrees is square root of 3 over 2. That's it. That's the output. Because that's what it's telling me. It tells me here cosine theta is just whatever my x is. At 30 degrees, my x was square root of 3 over 2. Right? All right. Let's go to pi over 6. Pi over 6 is still the same as 30 degrees. It's just a different way of measuring rotation. So pi over 6, cosine of pi over 6. That is also square root of 3 over 2, the x value. So it's the same. It just depends. So now you know. So let's see. So where are we going out with this? So if I were to go to Desmos, I just want to show you guys. So if I were to go to Desmos and I type in cosine, and I think right now it's in radians. So I'm going to type in cosine of pi over 6. Notice, okay, that is square root of 3 over 2. It just didn't come out with a square root on it. Look, SQRT, so square root of 3 over 2. So there it is. So check it out, guys. Isn't that cool? And if I were to go to degrees, so if I click on this little wrench here and I put degrees, well, of course it's going to change my answer. Let me change that pi over 6 to a what? To 30. And then look, cosine of 30, it says the same value again, because now it's a degree. Do you guys see what's going on? Okay. So now I think we're so close. We just need one last thing. And again, it's just so it's gonna change the way you think. So we're gonna have something called unit circle quizzes. And at first, people think that it's hard, but it's not. You can be very fast. You just got to make sure that you train your brain. So let me show you what I'm talking about. I'm gonna make them all the same. So I'm gonna write sine pi over 6, sine 5 pi over 6, sine 7 pi over 6, and sine 11 pi over 6. I want you to notice, if you look at the unit circle, that all of them, look at your unit circle. Look at pi over 6, look at 5 pi over 6, look at 7 pi over 6, look at 11 pi over 6. The magnitude of all, and sine is what? The x or the y value? The y. The magnitude of all the y values, as long as the denominator is 6, is always going to be 1/2. Yeah, be confident, guys. Always going to be 1/2. All of these are always 1/2. Now, the only difference is which one's positive, which one's negative. We know that sine is the y value. At pi over 6, you're in quadrant 1. Everything's positive in quadrant 1. 5 pi over 6. Oh, that's a 5. That's a 6. So that's quadrant 2. Is the y value positive or negative in quadrant 2? Positive. What about 7 pi over 6? That's in quadrant 3. In quadrant 3, everything is negative. Put a negative. And sine of 11 pi over 6. Oh, 11 pi over 6. That's double of 6, the 11. Subtract 1. So I'm in quadrant 4. In quadrant 4, the y value is negative. Look how fast you can be. You just got to make sure that your brain could. Okay, I'll stop. Let me slow down. And I'm not trying to offend you, I promise. You could. You guys are so good at memorizing, but some of you guys need way too much brain power. You could memorize each little element by itself, but look how much time that would take. And you would, you can memorize it. You trick me. Yeah, you know it. But guys, you don't have to memorize all that. Just know the little intricacies. Know, like, okay, I'm in quadrant 1. Everything's positive. And then all you got to know is just know quadrant 1. Know all these radians. So if I tell you, I'm just going to make something up, and I'm going to show you the way that you should be thinking. If I tell you cosine of 5 pi over 6, here's how you should be thinking. Cosine the x value, okay. 5 pi over 6, oh, okay. 5 pi in the numerator, 6 in the denominator, that's quadrant 2. And I'm in quadrant 2, so the x value is going to have to be negative. And all the 5 pi over 6, all of them, for cosine, they're all square root of 3 over 2. So if I tell you cosine of 5 pi over 6, you're going to tell me negative square root of 3 over 2. Do you see how we're doing it, guys? Or you can just keep referencing your unit circle, but make sure you know the little intricacies. So if I tell you, let's just choose another one at random. Let's see. Well, you know what? You tell me. Pick a rating.
7 pi over 4.
Okay, if I tell you, which one do you want me to use? Cosine or sine? Okay, well, that way, yeah, it doesn't matter. Cosine 7 power 4. 7 power 4, that's in quadrant 4 because it's double the denominator, subtract 1. You see that? And cosine, positive or negative? In quadrant 4. Positive, so it's going to be square root of 2 over 2. Do you see how we're doing it, guys? You don't have to be as fast. In the beginning, we're going to be slow, but you're going to get super fast. By the way, all the ones over 4 are the easiest because the x and the y coordinate have the same magnitude. They're always going to be square root of 2 over 2. You just got to figure out, is it a positive or is it a negative? Do you see how we're doing it, guys? Okay, any questions? Hit me. Did these notes make sense to you guys? For sure. You're not just telling me that just to tell me that. Do you feel good? All right, guys, I'll upload these notes tonight. Log in to Delta Math and just practice. You're just going to be practicing in the beginning.